Thank you. So as I was saying, the yellow color portion is the same. So from the original graph that we drew, it says y equals 2. That is why I placed it over here in part F, and I've ended up with an extra bit that is a combination of both equations. Y equals to x squared minus x minus 2 combined with x squared minus x minus 2 equal to 5. You see that this is a combination of both of them. Keeping in mind, we already drew the first equation. It's drawn already. Drawn. So, how am I supposed to find points of intersection? There is another graph that we need to draw. Guess what? It is simply y equals to 5. See that? They're all the same, right? Y equals to x squared minus x minus 2. And at the same time, it is equal to 5. They're telling you simultaneously, at the same time, y is equal to x squared minus x minus 2. At the same time, it is equal to 5. We already drew this, drawn. So what do we need to draw? Simply this. Draw this now. The line y equals to 5 is a horizontal line. Just draw it, you will get a point of intersection. That will be the answer. So for question 1F, this is what we are expecting it to look like. A quadratic graph. Equation y equals to x squared minus x minus 5. If we were to solve this simultaneously with y equals to 5, let's call this equation number 1. Let's call this equation number 2. If I ask you to solve them simultaneously, what would you have done? So this is what it will look like. Y equals to x squared minus x minus 5. Equation 1. Y equals to 5. Equation number 2, right? Do your substitution, do your elimination. You would end up with, since the y's are the same, x squared minus x minus 5 equals to 5. And then you continue to solve this. X squared minus x minus 10 equals to 0. Continue and solve. This will result in two values of x. X equals to something, x equals to something else. And they correspond to the x coordinate of the points of intersection of your two graphs. This is how we do it. We will understand a bit better when we look at the next question, similar type. Okay, so as shown, here we have a quadratic graph and our line y equals to 5. Intersecting one point over here. By right, if you continue drawing your parabola, there will be another point of intersection over here. But the question, I think they only requested for the range x from -3 to 3. That is why in this solution, which is already uploaded, the teacher stopped drawing the parabola at x equals to 3. The teacher stopped drawing here. That's why you only end up with one point of intersection. If the question didn't say stop at x equals to 3, we have to continue. And we will get a separate value of x. So we've got one solution over here of -2.2. We are expecting another solution. Okay, all these uploaded already. Let's look at the next one. Question 2, a ball is thrown. We have a quadratic equation again. What h? Instead of y, we have h equals to -t squared plus 4t plus 8. Negative t squared. It's a negative. So it's a sad face. We are expecting a parabola opening downwards. This is what happens when you throw a ball from the top of a building. You throw it. You follow the path. So after that, write down the range of the time when the basketball is at least 10 meters. Okay. So this is the diagram. When the ball is at least 10 meters, don't forget your vertical axis was your height. At least 10 meters, definitely we are referring to 10, the value of 10 on the vertical axis. Draw a horizontal line. find the points of intersection. Whenever you have more than one graph on the same axis, you must find the point of intersection. It is true for Sec 2 work, for Sec 3, for Sec 4. Subsequently, when you take AMATS, you're going to have more complicated graphs. But we will always want to find points of intersection. So whenever you find yourself having two graphs on the same axis, just run out a point of intersection first. Later, most likely you'll use it. So this tells us that, hey, there are two timings. The first timing is at 0.6. The second timing is at 3.45. What does this imply? It implies that at time 0.6, the height is exactly 10 based on the graph. It implies that, again, when the time is 3.45, the height is exactly 10 again. So what happens before the 0.6 seconds? What was happening on this portion of the flight of the object? Before 0.6 seconds, the height was 8. Then it increased. The height increased until 10. How long did it take? 0.6 seconds. Can you visualize what is happening? So if you imagine this table that I'm at is actually the top of a building. This is the top of the building. At time equals to 0, the object is still in my hand. I'm going to start throwing. So it follows a parabola. It started to go up, then come down. One more time, from here, throw up and down. So from 8 meters, that is the original height of the table. You see that in your graph. At time equals to 0, the height is 8. That is something they didn't, I don't think they asked you for it, right? Did they ask for the height? Yeah, they didn't ask you the original height of the building. But the original height is 8 meters. After 0.6 seconds, by slow motion for you now. After 0.6 seconds, it reached 10 meters. Beyond 0.6 seconds, it continued traveling higher and higher until a maximum point reached at 2 seconds. Then it starts to go down again. Go down to 3.45 seconds, and then it reached our same 10 meters again. Then after that, it continued going down, down and down. This time it went below the 8 meters. It went below the height of the table already. From the table all the way down until the height is 0. So this is the situation over here. Then if they want us to find the range of time when the ball is at least 10 meters, referring to this interval in the middle. So our answer will be from 0.6 to 3.45 seconds inclusive. Or do you agree that your value may be different from 0.6? Maybe it's slightly more, slightly less. It's okay. We don't expect you to draw perfect graphs. But if your graph is horribly drawn, you will lose the accuracy mark. Okay, next portion. So this is the one again on the points of intersection of curves. In this diagram, we have already given you the equation of y equals to x squared minus 5x plus 6. This is a parabola opening upwards. Smiley face. Why smiley face? Because our coefficient of x squared is positive. This is a positive 1. Okay, so smiley face. Now, if you want to solve simultaneous equation of y equals to x squared plus 5x plus 6, already drawn, huh? Want to solve it together with, for example, y equals to 0, which is otherwise known as the x-axis. We will have to draw the line y equals to 0. And then from there, we look for the points of intersection. One over here, another one over here. In other words, these are commonly known as the roots solutions. The values are 2 and 3 respectively. If you were to solve x squared minus 5x plus 6 equal to 0, you will get x equals to 2 or x equals to 3. Now, using the same parabola. Same parabola, we don't want you to do any more extra work. Ignore this diagonal line. We want you to use this graph to solve x squared plus 5x minus 6 equals to 2. So watch how this is done. X squared minus 5x plus 6, we already drew that. But there was an extra y equals 2. So you include the y equals 2. So y equals to x squared minus 5x plus 6 equals to 2. This is us combining two equations into one line. The first half, y equals to x squared minus 5x plus 6, is drawn. The second half, x squared minus 5x plus 6 equals 2, is what they want us to solve. So you need to draw another graph. What is the other graph you need to draw? Cancel with the middle. The answer is that. Draw y equals to 2. All right? In the same diagram, draw y equals to 2. So y equals to 2 is a horizontal line. Y equals to 2. Find points of intersection. 1 point here. X coordinate is 1. Another point, x coordinate is 4. Done. Solution, x equals to 1 or x equals to 4. As shown. Next case, part B. Again, use the same graph to solve. Okay, x squared minus 5x plus 6. We already did that. Put on your y equals to. Or we have just combined two graphs into one line. Oh, sorry, two equations into one line. The first half, y equals to x squared minus 5x plus 6, is our parabola already. The next half of the equation is, so from here, just cancel off whatever is in the middle. You are expected to draw y equals to 6. So draw it. Y equals to 6. Find the points of intersection. So here's my line. Y equals to 6. I have two graphs on the same axis. I must find point of intersection. The first answer, 0. X equals to 0. The second value, x equals to 5. So the solutions are x equals to 0, x equals to 5. These are basic types of questions. We are going to give you more complicated questions, such as part C. Part C says, using the same graph, solve this. X squared minus 5x plus 6 equals to x plus 1. Notice that the left-hand side is still the same. X squared minus 5x plus 6. What are we going to do? Put a y equals to. We have already drawn the first half. Don't waste time doing it again. Now, cancel away whatever is in the middle. Your answer is that. Draw y equals to x plus 1. Draw y equals to x plus 1. In order to draw y equals to x plus 1, you will need a table of values. Plot it out. Y equals to x plus 1 as shown. This diagonal line. Y equals to x plus 1. Find the points of intersection. 1 and 5. The solutions are 1 and 5. Okay. Then I have a part D for you. Now your job is to write down the graph that you have to draw. Okay, based on my question. I want you to use your graph to solve x squared minus 5x plus 6 equals to -2. Tell me what you need to draw. That is good enough. Okay, so you can do whatever kind of working you like. Eventually tell me what to draw. Draw y equals to. Okay, now everybody try. Okay, so next one, instead of equals to x, let's have the right hand side as x minus 3. What do we draw? Yeah, we draw y equals to x minus 3. For this, we'll need a table of values. Then where the graph intersects the straight line will be the solution. The x coordinates are the solutions. So next, Nadira, we have x plus half. Okay, so what's the answer? X plus half. Okay, ready for more challenging questions? Yes, yes. Can. Try. Okay, watch. Instead of plus 6, I have plus another 1 equals to 3. Okay, how? Keeping in mind, I already have the graph of y equals to x squared minus 5x plus 6. Yes, what should we do? Y equals to 4. What was the pattern earlier on for the 1, 2, 3, 4, 5? For the first 6 students, what's the pattern? My left-hand side was always x squared minus 5x plus 6, correct? And I already have a parallel for x squared minus 5x plus 6. If I have that situation, I just need to throw y on the right side because I did it. Whatever it was, just write out y was whatever it was. But this time, the left-hand side says x squared minus 5x plus 6, then plus 1. Then plus 1 is equal to 3. What will we try to get rid of that plus 1? How do we get rid of the plus 1? Yeah, you minus it when you minus 1, isn't it? If you minus 1 on the left-hand side, if you minus 1 here, then what will happen to the right-hand side? 3 minus 1 becomes 2. So what should we draw? 2. Y equals to 2. That is what we should draw. Get the idea? Okay, so your turn, huh? Minus 3 equals to 1. Okay, Chloe, what should we draw? Y equals to 4. Straight away, you get the answer already. You are correct. We need to get rid of that minus 3. Why do I want to get rid of that minus 3? Because I want to see x squared minus 5x plus 6. Because that is what I have already drawn. So you get rid of that negative 3 by adding 3. You add 3 to the right hand side, you end up with y equals to 4. All right. Next one. Samuel, you want more challenging or same standard? More challenging? More challenging, lah. Let's put this as a 9 and 1. How? Draw y equals to negative 2. Correct? Is this your final answer? Okay, so he says he wants to draw y equals to negative 2. Then they will ha. So what happened? How did he get that? 9 minus 3. Why should we minus 3? Because I want to get a plus 6. In order to get a plus 6, I need to minus 3 on both sides. Then the 9 will become plus 6. The right hand side will be 1 minus 3 equals to negative 2. And this is correct. Okay, we think? You ready to try? You can do it. You want a similar one or easier or harder? Which one? Same, okay? Same one, huh? Let's change this to negative 1. Okay, let's see how you do it. Negative 4, huh? So we need to minus 3. Yes, you're right, negative 4. Okay? So now, Sean, harder. Let's put a 6 plus x equals to 1. Okay, let's try this. Sorry? 1 minus x. Draw y equals to 1 minus x. Do you all agree? What is the objective? The objective is to make the left-hand side look like x squared minus 5x plus 6. So what did he do? Get rid of the x, minus x. And yes, it is correct, 1 minus x. Too easy already. Harder. Okay. Can. Let's make it harder. 3x plus 8 equals to 1. Okay, so how? What should we do? Negative. You mean here minus 1, huh? What do you mean? Is that your final answer? Negative 1 minus 3x. Is it? Is it correct? Yes, it is correct. So the first thing that he had to do was to get rid of this 3x by subtracting 3x on both sides. Now it is starting to look like what our graph is, x squared minus 5x. Then instead of a plus 6, we had a plus 8. So we need to change this to become a plus 6 by subtracting another 2. Subtract another 2. So we end up with 1 minus 2 gives us negative 1, and 0 minus 3x gives us negative 3x. Okay? Zhen Jie? Ready? Not yet. We still about 1 minute. 4x equals to 0. Okay, how about this? Negative 4x. Huh? Okay, wait. How much? Negative 4x plus 6. Okay, so what did you do? No, tell me lah. What do you do to both sides? No, try. Okay, tell me what's the problem. How is the existing expression different from what we have drawn already? How are they different? Yeah, we've got a plus 4x, right? So we need to get rid of that 4x by subtracting 4x, isn't it? Then after that, we didn't have the plus 6. So I need the plus 6 to the right hand side. And therefore, you are correct. Get it? Okay, maybe the last one already, Aloysius. Aloysius, give you something like this. 8x, 10, 0. Okay, let's try this. Minus 4. Okay, then correct. You guys get how to do this now? Because we don't have time, otherwise we will continue, okay? So after you know what to draw, you find the intersection. We are only interested in the x value. We are not interested in the y value. Why? Because when I ask you to solve these equations, there isn't a y inside. It is all x. You are finding the x value, okay? Tomorrow, our lesson, we will focus on part E for the next one, and we are done.